Okay, so this is part 2 of the Opt4 Day 23A study guide, and we're on number 11. So number 11 says to find the probability of A occurring and then round your answer to the nearest thousandth. So this is a spinner, and we're going to assume that all of these sections are equal space. So we basically need to see how many there are and then how many of them are A. So there's 1, 2, 3, 4, 5 of them are A. That's going to be your numerator. And then our denominator is there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and for whatever reason, we want to write that as a decimal rounded to the nearest tenth. I don't know what 5/12 is. Okay, but it's 0.4166666666, so we round that to 0.417. This is not being written as a percentage here. All right, number 12, find the probability of B occurring, round your answer to the nearest thousandth. So how many of them are B's? There are, let me use a different color here. 1, 2, 3 out of 12. Which is a quarter or 0.25. Okay, then you do C the same way. How many of them are C for number 13? Just 1. And then, so you divide 1 out of 12 and get 0.083. And then there's a follow-up question, number 14. Oh, you got to do D. D, let's see how many of them are D. There are 3, so that's going to give you 3 out of 12 again, which is 0.25. So that's how they got the 0.25 for number 14. Okay, and then the question is the model uniform or non-uniform? So basically, are they all the same or are they different? They were not all the same, so that is non-uniform. Okay, so non-uniform means different probabilities. Uniform means every option has the same probability. Okay, number 16, what is the probability of the spinner not landing on A? So if the probability of getting A was 5 out of 12, the probability of not getting A, which is sometimes shown with this little symbol here, is basically going to be 1 minus 5 out of 12, which is 7 out of 12. You could also just count all the options that were not A, and there would be 7 of them. Okay, then we get into the counting principle. Use the counting principle to calculate the size of sample space in each situation. So we're not doing probability, we're just doing the counting principle. So number 17 says you roll a 6-sided die or cube 2 times. So basically, because we're doing it 2 times, I'm going to put 2 spaces here. I'm going to multiply for each roll. For the first roll, you can get numbers 1, 2, 3, 4, 5, or 6. So there's 6 ways you could roll the first one. For the second one, you can get 1, 2, 3, 4, 5, or 6. So there's 6 ways to roll the second one. You multiply that together, you get 36. Number 18 is also a counting principle question. It says a restaurant sells 6 different types of sandwiches. You go to the restaurant 6 times and randomly choose a different sandwich each time. So I'm going to the restaurant 6 times. So I'm going to put 6 numbers. Let me fill in one over here. Okay. So then the first time I go to the restaurant, there are 6 options. But then I'm choosing a different sandwich each time. So the next option, next time I can only choose 5. Then the next day I can only choose 4. Then 3, and then there's only 2 options left, and then the last day there's only 1 sandwich that I have. So essentially this turns out to be 6 factorial, or 720. Okay, number 19, unfortunately this picture got messed up. Okay, so for number 19, you have to draw 2 balls from the number box and 4 balls from the letter box, and we're trying to figure out how many ways that can happen. So think about how many ways you're going to draw something. So 1, 2 from the number box, 1, 2, 3, 4 from the letter box. So that's like 6 things. How many numbers are there? At first there's 4, but then since we're taking 2 of them when we're not returning them, the first one we did not put back, there's only 3 for the second time, so we have to reduce it. Then from the letter box, there's 1, 2, 3, 4, 5, 6, 7 letters to start with, and then it's going to go down by 1 for each. Okay, and those are the numbers you're going to multiply all together to get 10,080. Number 20, this is not from that same group of questions about the counting method. Now we're back into probability. It says 2 groups of discs are as shown. Okay, we got group 1 with colors and group 2 with numbers. If you randomly choose a disc from each group, what is the probability of choosing a yellow disc and a disc marked with a number 4? So since they're grouped separately, the 2 events aren't really going to affect each other. So let's find all the yellow ones. 1, 2, 3, 4, 5. So there's 5 yellow ones out of 1, 2, 3, 4, 12 in group 1. Now this says and, choosing a yellow disc and a disc marked with the number 4. So that's the probability of getting a yellow disc, and we're going to multiply. Probability of getting a number 4, 1, 2, there's just 2 of them out of also 12. Okay, we can reduce this a little bit. This could be 1 out of 6, which gives us 5 out of 72. Okay, number 21 and 22 are all about this coin. It says you flip a coin 4 times, type your response as a simplified fraction. So 21 says, what is the probability a coin will land on heads for the first 2 times and a tail for the last 2 times? Okay, so these are independent events. Getting a heads the first time doesn't affect the probability of getting a heads the second time. So we need the probability of getting a head times another one of those, and we need tails 2 more times. Each of those is a half. 1/2 times 1/2 times 1/2 times 1/2, which gives you 1/16. Okay, 22 says, what's the probability the coin will land on heads all 4 times? Okay, since the probability of a heads or tails is a half, it's going to be the same thing. So you get 1/16 again. That was the end of that one. Okay, now the blocks. Consider the set of blocks shown. Enter the answers as a simplified fraction. If you choose one block, replace it, and then take another, what is the probability that the first block will have an E on it and the second will have an X on it? So there's 12 blocks. So we need the probability of an E, and then we're going to multiply that the probability of getting an X. Because it says, oh, wait, no, this says or. So we're not going to do multiplication. We're going to do the probability of E plus the probability of X minus the probability of E and X, which is when you multiply them. Because I had to look for the word or here. Okay, so how many E's are there? Probability of getting an E, there's 1, 2, 3 out of 12 blocks total. Probability of getting an X is 1 out of 12 blocks total, minus the probability of E times the probability of X. Okay, I am going to need common denominator here. Let's see. I can reduce this to 1 out of 4, which makes this part 1 out of 48. These already have a common denominator. I can add those to be 4 out of 12. Now to subtract them, I'm going to need a common denominator, and I'm going to use 48. We'll do 4 over 4. I'm going to finish it over here. That's going to give me 16 out of 48 minus 1 out of 48 gives me 15 out of 48. Now, how did they get 5 out of 16? They reduced it by 3 because 48 is divisible by 3 and it gives you 16, and there's your answer. Okay, number 24, same setup. If you choose a block at random, and this time without replacing it, choose another, what is the probability that the first block will have a V on it and the second block will have an S on it? So we're going to do the probability of V plus the probability of getting an S minus the probability of V times the probability of S given that you already took a V out, which is going to change that one. So let's see how many V's and S's there are. Okay, there's 1 V and 2 S's. Okay, so the probability of getting a V is 1 out of 12. Probability of an S is 2 out of 12, right? Let me just double check that. That was 1 V and 2 S's, right? Yes, okay. So then I'm going to subtract the probability of a V and times the probability of S given you'd already taken a V out. So that's going to be, there's 2 S's, but there's only 11 blocks. So you have to change that denominator because you did not replace it. So then we can do a little combining. 3 out of 12 minus, we can do a little cross canceling here. 2 goes into 12 6 times. So 1 out of 66. 3 out of 12 is 1 out of 4. You know what? I'm going to back up a bit and not do that cross canceling so that it'll make my common denominator a lot easier. So I'm going to keep it 2 and 12, so it'll be 2 out of 12 times 11 is 132. The reason I'm doing that is because it's going to make my common denominator easier. So 12 times 11 is 132, so now I'm just going to multiply this by 11 over 11 to get 33 out of 132 minus 2 out of 132 to get 31 out of 132. Which was the answer. All right, number 25. A bag contains 11 marbles and 11 blue marbles and 12 yellow marbles. You randomly choose marbles from the bag without replacement. That's important. Enter your answers as simplified fractions. What is the probability that you will choose a blue marble first and then a yellow marble? So without replacement, and it says and. So the probability of getting a blue marble times the probability of a yellow marble given you have already taken out a blue one. So altogether there are 23 marbles. So the probability of getting a blue is 11 out of 23. Okay, we are not replacing that marble, so we now only have 22 marbles, but they're still all 12 yellow marbles. Okay, we can do a little cross canceling here. 11 goes into 22 twice. 2 goes into 12 6 times. Oh, there's your answer, 6 out of 23. Okay, number 26. What is the probability that you will choose 2 yellow marbles? Each choice is without replacement. So the probability of yellow was 12 out of 23. Okay, but for the second yellow marble, you took one of the yellow marbles out, so now you only have 11, and you only have 22 marbles altogether. We can reduce this. This is going to be a half. And then the 2 can go into the 12 6 times, and you get 6 out of 23. Okay, same setup. You choose 4 marbles. What's the probability that the first of the 4 marbles is blue? So how many of the marbles are blue? There were 11 of them out of 23. So we're going to do 11 out of 23. So basically think of this as the probability of getting blue. And then we don't care what the other 3 marbles are. So the probability of any 3 times. Anything that's left, because we don't care. This actually makes it really easy. The probability of blue was 11 out of 23. The probability of getting any marble after that is just 1. You're guaranteed to get something. So that's why it's just 11 out of 23. Okay, that was it. I hope you found this helpful.